No, no, they didn't. They didn't. Maybe they bought it from the US, but they didn't buy it in Canada.
I heard
Very common. Very common.
it was really, that's the shame.
Not really. They stopped. They were stupid. They.
I think there's a different time of the
Yeah. So Flix is running Montreal and Toronto buses on some ill-defined schedule. There was a different Quebec subsidiary of Greyhound called Orleans Express, which is running buses in Quebec. They still exist, but as far as I understand, there's no buses to Ottawa. In fact, the bus station, has fences around it, waiting to be opened. Okay, so I don't know where if there is Flix, I don't know where they stop or where they go.
It was just in the news.
Well, you're the one who's telling me that like North American public transit actually works. I seem to remember you trying to sell me like I should take a bus or a train somewhere, and I'm like, you must be crazy.
You were drunk that day.
You were like, no, it works.
I wasn't even part of that conversation. You were just delusionally putting me there because you needed an advocate to try to convince you what you already knew. You just projected me as your advocate because I was the person you most associated with public transit.
So we are officially starting this meeting kind of now. I know this is a late meeting on Friday, and apparently I'm stranded here without my dear co-chair, Alexei. This is the IoT Operations Working Group meeting at, I want to call it the zombie slot. But welcome. He's at the airport already, unfortunately. There was no other way than to do this. So let me go to my slide deck.
Please, everybody sign into the echoes, because otherwise they won't believe that anybody showed up.
I mean, my number here is 22, so we're winning here. Attendees, any second now. So please be aware this is a recorded meeting because this is under the notebook of the IETF. If you're here for a while already, then you're probably pretty familiar with that. I want to highlight if there are any conflicts that you encounter, just try to be nice to each other and reasonable. Also, if you're not aware of these BCPs at the bottom of here, read them, please. They will pretty much walk you how the IETF and IPR works. There's a new addition to the Meet Echo tool. You can see a QR code here. In the room, you have on the Meet Echo side this new cell phone icon. That is how to raise your hand inside a room. That's really useful, not to discriminate the remote attendees that we can actually order line. Please use that. You can also still use the full Meet Echo and raise your hand there. This is all summarized in the Meet Echo basic guide. I gave you a quick tour. If you have any issues that you encounter, please help us make Meet Echo a better tool. There's an issue link for that at the bottom of this page, page 4. Yeah, my name is Hank. Alexei is unfortunately missing an airport. We don't have yet a assigned JavaScript. Would somebody like to take that up?
I can do Java.
Yeah, that would be awesome. Also notes. I don't think it's a hard thing. Notes can be reached via the Meet Echo site. There's this little notepad icon on there next to the IoT Ops item on the session thing. But it's also here on this slide, and Michael just raised his hand. Thank you for that. Yeah, well, pretty much everybody should have found Meet Echo by now, but there's still a link. We have a few items today. Mostly it's reporting on work that needs some cross-pollination, so that's great, I think. We have, I think, a very interesting new item on authentication methods here, a report of SNAC, that's nice. We will have about the DEFT. I think that is, I think, overall a very interesting topic. I actually have not read a lot of the Internet Exposure Analyzer yet, so I'm really curious about that one, but I'm also such a, so I heard a little bit. And then we will talk a long time today. It will probably take a long time today to talk about what we're going to do in the next years. So there's a candidate for adoption here, and Brent will talk about that. And that will require, that's why this is plus 20 minutes, I think a little bit of finding ourselves there. I know, again, at this time we are 32 attendees. That is not the best situation to make guiding decisions in a room, but I think we can have tentative discussions on where this journey can go. And I want to give the opportunity to Besh the agenda right now. If anybody has something to add to this, please speak up or raise your hand in the queue or whatever. I go with the mic. Going once, going twice. The agenda is fine. And we can have an open mic. So if everybody changes their mind, there will be time for that. So this is the introduction slides from my side. Quickly looking back at the agenda, we are starting with Hannes. So I will pick that and share it. And I hope that works. Looked pretty fine recently.
Okay. Yeah, it's a relatively short presentation because I don't want to repeat what I had said in other presentations before, but I would like to, there was one presentation on Sunday at the Hot RFC and another one on this topic during the TLS working group meeting. But since the week is over, we had many discussions. I would like to reflect a little bit on what I've heard, and maybe you find that interesting too if you work in this attestation space yourself. Okay. So this is one of the models outlined in the RATS architecture model. This is the background check model, one of the two models that is used to pass evidence and attestation results around. And one where I found out during the week, and I've seen other proposals beforehand, there are different ways that people think they should be sending evidence and attestation results around. In this for the background check model, this would be evidence sent from the tester to the relying party, which is then sent to the verifier, and the result comes back to the relying party. That's what I explained in case of the TLS, embedding this information in the TLS handshake during the TLS working group session. But there have been other proposals sort of outlined during the meeting this week. For example, I want to highlight the use of attestation information in X509 certificates. So that would then equally go into the TLS handshake because the certificate there is as well. It's just a different layering of that information. And then, of course, there are ways to relay that information at the higher layer in the protocol stack. There's a proposal by Intel on how to embed this in HTTP, but there have been also proposals to do it higher up in the application layer, for example, on top of co-op, not as a payload in for example, lightweight M2M. Okay, that's kind of the state of affairs. So lots of different activities. So that sort of gives me a little bit the impression that there's broader sort of a number of industry players being interested in utilizing attestation information that is provided by hardware in some of the newer platforms and make it available for all sorts of different use cases. Next slide. As I mentioned, like I talked about the TLS based version, and that was an initial version like many of the other documents or solutions I've briefly mentioned. After the meeting, Nat Smith came to me and we agreed that we would be working on a comparison because there are subtle differences between the different approaches. So it's not irrelevant on where you stick information in and how you do that. So certain use cases favor one approach versus they are probably less than ideal in other cases. So we wanted to highlight this and bring this to this group potentially because it could be a good I think a good item. It doesn't naturally fit into other groups per se, like in RATS or in let's say the DLS group, or like what other group. So maybe this could actually be a home for such a comparison document that then points to the other documents that are being worked on in the IETF. That would also, since there's also a lot of commonality. For example, I was asked about use cases and with the background of like how does privacy influence those use cases. So those the privacy aspects show up regardless of whether you carry something at let's say the TLS layer versus in a certificate in the TLS layer. One other thing for those who are participating in the confidential computing consortium, which you, by the way, you can join the meetings even without being a member of the consortium. So those are public meetings; they are held on a regular basis. So if that type of sort of technology is of interest to you, feel free to join. And they're also collaborating on projects. So there are a number of software projects in the CCC already. For example, on some of the enclave and technologies. And so we will be contributing the implementation work or POC work on this topic to the CCC. And there will be discussions next week on that. Assuming that it works out, you will hopefully see some code in the near future you can play with. And yeah, with that, I want to conclude. So if any one of you is interested in any of this, would like to try out implementations or work in the group somehow, want to be involved in the discussions, let me know.
So already 3 people lined up, and Jari is first.
Yeah, Jari Arko. So first I wanted to support this work. I think it's important, we need it, and please go ahead. I'm certainly personally interested on this. I don't have a huge comment on this, like the details of the different variants, which one is the right one, and so forth. Yeah, you guys have to work that out, or we have to work that together. But I think, based on my experience at least, when we're building some things that needed these types of attestation designs, then it was our preference that we would have had like libraries available that, the standard TLS library would enable to do this, or would allow us to do that based on our requirements and so on. And it could be in some other libraries, but it felt at the time at least that there's like clear need for this, but not a lot of standardization or available implementations in the different toolkits. So I think both as open source and the standardization aspects are important. So I'm happy to contribute if that helps.
Yeah, I wonder whether it would also be useful to maybe at the next IETF meeting, maybe hackathon, to actually sort of play around with some of that software stack, because it's obviously there's a lot of different components, and each component by itself may be fairly simple to use, but once you glue everything together, it gets complicated.
I think that would be useful, and I do think that it does get complicated, and that's also maybe a point to be thought of when like you brought up this, that there's different ways of doing this, and when we have 15 different options, what happens to interoperability. So that's not necessarily great.
That's true. I was more referring to in this case. So with confidential computing, you have a lot of layers of software. Like you need to have some normal word software. You have these enclaves. The software is running in the enclave or in this trusted execution environment, and so there are piles of software that you would normally, as a developer, not deal with. And so that may be new and maybe it's surprising. So maybe that could be an interesting sort of exercise to get something working and have a working system at the end of the hackathon.
Michael Richardson, I haven't read this document, but the title sounds really good, especially if you were to append for IoT devices at the end. But I guess I think it would be I'm not clear why this doesn't belong in TLS or RATS, but on the other hand, you know, this working group has not adopted any documents, and I think that this actually sounds like the kind of thing that we were kind of chartered to do. So I think that would be really cool, and I'll go read the document, and I totally agree with you that this would be also a good hackathon kind of effort, to put the different things together, and that, you know, that 2020 Berlin hackathon was also really a good kind of thing. Anyway, we should do something like that again. Thanks.
Thanks, Mike.
So next is me
Henk?
as a contributor, so no heads. I like that your title slide is called attestation, and that you think you know what that means. And actually, as a contributor, that is a really hard thing out there. So I will put something to the chat here right now. That is a link. I saved it while we were preparing this, actually. It's from NIST, and it tells you what attestation is. And it is not what you think it is.
Okay.
It's derived from ISO, I think, 17000, and it's basically endorsement.
Mm-hmm.
So, and this is a whole SBOM space. So I think when you compare approaches, you should also, and I actually would willing me to contribute that part, because I'm like a broken record. When I'm starting a sentence with I'm like sounding like a broken record now, people start to laugh because they already know what I'm going to say.
Yeah.
Because this is an overloaded term, and a lot of people mean endorsement with this.
Mm-hmm.
There's no evidence involved. There's nothing in this diagram you showed involved. It's just saying I have some opinion about the software, and I'm signing my opinion with an identifier about the software at the end.
Mm-hmm.
So that is very complicated, and it's really making people talk past each other. So such a comparison is also, of course, I think somehow maybe in a dimension here. And then I don't know. Usually I see net on this slide. That's HTTPA, right?
Yeah.
Okay, excellent, because that would perfectly fit into this comparison. Okay.
Yeah. So that would be so there. That's the HTTPA, which is not in the IETF, and maybe it will be.
Yeah, they should go HTTP. This is on record now.
Yeah, and then
Put this into the minutes.
there's extensions to X549 certificates that were presented during this week's meeting in the BigX working group. And then, as I said, like there are other approaches at higher layers. So there's a lot of interesting work, and maybe it doesn't matter that much on like everyone should do whatever they find best for the use cases, but illustrating on what technique works best in what use case could be useful.
Yeah. So the incubation document will not be the TLS attestation document, right?
That's true. Yeah.
So we have to start some nucleus somewhere, and you will do that, I assume.
Yeah.
Okay. Great. Thank you.
Okay.
So coming up next, I should know my agenda better. Is Michael? Okay, yeah, your snack report. Do you need slides for that? I didn't get slides. That's why I don't find slides.
Yeah,
Makes
no.
sense.
So that's going to make it's really short. So on Monday morning, first thing by Hannes, there was a BOF on connectivity within mostly home networks called SNAC. If you weren't there, that's sad for you, but that's why you're listening now. My summary, my 1-minute summary, is that it looks like we will have a working group formed soon, and that the charter was well discussed and the problem statements was reasonably well understood, and that if you weren't involved in it, you probably should think about it, and it's pretty relevant to connectivity in the home for IoT networks. So that's really it. I just wanted to let you know, and I have no official standing in any of that process. So, but I thought it was important that we put it on this agenda. Thank you.
This was pretty much not 5 minutes, but thank you. Going from there, the next one is Dirk. Okay, I'm getting your slides up, I think.
Thank you.
share this. Let's see. I wanna do the right one. Let me check again. Why is it off? Things so hard to find. It's just a tiny bit. Ah, there it is. Okay.
Right.
And here we go.
Thanks a lot. Yeah.
Sure.
So my name is Dirk von Hugo. I'm with Deutsche Telekom still, and together with Beshet Zarikaya, we have been working on some time on the question: what could be one of the major applications for next generation networks? And on the next slide, surely that's not you surely know. So we think that things like IoT applications will be in the future very much important for environment, yeah, okay, no, will be important for everything, I think. Somebody say already 5G is the network for IoT applications, but perhaps more and really ultra massive IoT will only come afterwards, when we have really heterogeneous access networks, when we have more cheaper devices for everybody and for a lot of applications. And of course, there's a lot of different aspects with IoT. They have to be highly efficient, have to be highly reliable. And if there's so massive amount of devices deployed, then the scalability is very important. But the last and not the least, of course, is the security, because we think if everybody in his house has a lot of devices and it's too easy to attach them or to access them, this of course opens big risks. Distributed denial of service is only one. A lot of more, I think, will come into play, and therefore we need here strong access admission control and a strong authentication. And this is what we had on this next slide, that we say, okay, we think, okay, usually we have some kind of, on the left side, industrial IoT, like for the power grid and for vehiculars and for industry and so on. These are devices which are normally, by definition, high-end or kind of platinum devices with a very elaborated and complex, we say 5G-like kind of security capabilities. But if it comes to the household appliances, like on the right side, they are normally just very affordable and should be convenient for the user to deploy and install them. And this may be a question of what's the cost, but it will perhaps not be 5G and a SIM card inside, but other kind of authentication should be used. And what we think, if we really go to such a massive amount, then based on human intervention, like there are 802.1x, this does not really fit for this use case. And therefore, we provided this, or we think the term hardware-based authentication means that we have in the device also a interface for detecting or sending video signals, sending LED light or audio streams or something, which the device, the access point can detect, and from that authenticate the device would be perhaps a good idea, or is already proposed also as out-of-band channel. You surely know Ip6 which uses this. And it also then fulfills this two-factor authentication, that we have something independent of the communication channel. The second one to authenticate, that we think for this we should think about this procedure, how this could be designed, or how this would look like. And and beside this video audio, there may be also detection just of gestures of shapes or so, and this is on the next slide, I think. Then,
oh, sorry. Yeah. Focus of Windows.
Yeah. Okay. Thank you. That these dumb devices, perhaps it may be even too costly to have an LED light in this device. So but there are, that's later on, but in the beginning we said we have kind of requirements or challenges set up that, for instance, the user who is installing the device and the device themselves are separate and not physically connected. The user has not to be there to do the installation or the authentication to the network. And also then there may be a unique identity for the user and all his devices, or an identity where the identity of the devices can be derived from. So that is more easy for normal users like me to install this at home. And of course, then the authentication should be mutually, so the device should authenticate to the access network and vice versa, the access network to the device. But it should be anyway very simple, because the devices should be cheap. So there should not be required that there's a pre-established relation between the devices and the application or the server or whatever it is, or the users themselves. And that also not device identifier should be pre-provisioned via fabrication, or also any authentication credentials. And that this second input or output interface for the out-of-band channel may be only one directional, so just sending some light, or sending, playing a melody, or just any, doing some activity without detecting it. And yes, as I said, this additional interface, like LED or audio, for this out-of-band channel may be a cost factor. So we had the idea, or we found that there's this radio signal sensing, which is both done at the IEEE with Wi-Fi sensing, but also in 3GPP for 5G and 6G RAN. They have these studies, so that we have one antenna for sending and receiving the signal and analyzing the signal modification by the environment to provide the second channel. So but this is only one example for how to do it, especially because perhaps we then don't need line of sight and have any other requirements which may be required for LED. But the method, of course, should be independent of this technology itself. And I think in the next slide, we have then some kind of a idea how such a message sequence chart could look like between the device and the access point, which senses this second channel, or this token, or this information sent by the second channel, and then of course is connected to kind of an AAA client and AAA server, where this information is then acknowledged, and then in the end, then the device is given the admission to access the network during the bootstrapping procedure. And this is just quite rough idea. We have not so much information, or not so much thoughts already spent on which parameters could be provided between the IoT device and the access point. So what is the capability of the access point to detect which kind of signal, or what the device can provide, and how to characterize it, how to categorize it, or a generalized description of how this token should look like. So this is all which has to be maybe specified later on. And then also about the naming of the device, and perhaps a renaming of the device if it is reused in another environment, and whether how this could be combined to the geospatial information on where the device is placed. There may be standard parameters to be used. And of course also then what is existing already with the sensing access points by IEEE. This does not allow for a mesh setup for multiple meshed access points, but just for a single one. And this should be also then technologically extension, and also multicast communication should be perhaps provided and enabled. And that's then what we think we have perhaps to extend the existing RFC 91 140 on this nimble out-of-band authentication for ERP to EAP to allow for these requirements to be fulfilled, and perhaps even much more we had not yet in mind. But yeah, therefore we bringing this to this working group and asking for a review. It's on the last slide I have there now. This is now the 02 version. We had done some improvements since the 00 version, also discussing with Michael and others. And yeah, we would like very much if somebody can review and look at the document and comment on it, whether this is useful within this working group. So at the moment it is more a problem statement, but perhaps it can point towards some possible solution space. And yeah, and that would be then perhaps in the question later on to adopt this as a working group document if you think this is interesting. Yeah, and with this I want to thank you, and questions either now or also we can be contacted.
Yeah, are there any comments or questions immediately from the room or remote? If not, my question would be, is there anybody willing to have a look? So you were asking for a review, and sometimes putting people on the spot helps. So is there anybody interested here on the remote to have an immediate look at this? Or is this out of your scope? And there's somebody joining the, oh, I should have paid attention to that. Yes, Janfred.
Yeah, hi. I haven't read the draft. I would be willing to read it, and especially since you mentioned IPNoob. And in EMU, I'm looking into IPNoob, and I've found some issues with it, and I'm currently working on another draft to redo the same thing, but not with JSON, but with CBOR. So I would be very interested to see, or I would take a look at the draft, and I would be very interested if you're interested as well to collaborate maybe on looking into how IPNoob or then the new specification could fit into that.
Thank you.
Okay, thank you.
Always make sure that review comments are visible, so emails to the list are, of course, in this context welcome. Yaris next.
Jarko. So I think this is interesting. I have read the draft briefly, and I think yeah, out-of-band mechanisms that help authentication of devices that are different from our traditional big devices is obviously an important topic. As you mentioned, there's plenty of prior work from this EAP methods that we mentioned to many others. I also happen to have worked a little bit on the sensing space, and I sort of got the gut feeling, at least, that it's a little far at the moment from like practical application, given that we don't actually know the details of accuracy and so on. So it may not be the first thing to focus on. Perhaps that's my gut feeling, at least. That some of the other things are more readily available, and their characteristics can be better determined. I also think that your security consideration section, which was pretty empty, probably needs some considerations, because I'm guessing there are some actual issues, like how do you prove that there actually was something here and it wasn't in some other place, and can someone simulate one thing that looks like another one, and so on. So yeah, but good stuff. Please keep working on this.
So if I understood you correctly, you think we should more focus on less aspects, as mentioned here, especially on the technology of the sensing, which is more future-looking, right?
Yeah, I don't know if I'm right. It's just my gut feeling that the using sensing as the out-of-band channel is, it's an interesting idea. It may not have immediate practical applications, given that the stuff is still sort of in the works, and we don't really, we can't immediately experiment with it, whereas some of the other techniques are more readily available.
Okay, yeah, thank you. At least we had in mind to be more general, so not only focus on this sensing, but also on the other methods which are available still. The best, of course, would be to have some overarching concept which is working for everything. Okay, but everything is, again, too much.
Okay, any other questions? Sorry. Well, thank you.
Thank you. Thank you.
I'll select the next presentation, which I think is DEFT.
Okay, can you hear me?
Yeah, we can do.
Okay.
Oh, I found it.
Okay.
It was not in the title. So there we go.
Okay. All right, so this draft is about a new transport protocol, and this isn't a transport
just
protocol.
let me interrupt you real quick there. Are you comfortable turning on your camera?
I did turn it on. It's on and it's unshuttered, and I have it says a screen request. And, oh, whoops, wrong thing. Sorry. Okay, got it. Okay, am I on now? Okay, great.
Yeah, you are now.
Okay, so this is not a transport protocol that is meant to compete with TCP or QUIC. It's really meant for limited domains like we encounter a lot in IoT. So, why would we do this? So we thought that there was a serious unmet need that's very difficult, if not impossible, to meet with today's transport protocols. So do I have control of the slides, or next slide would be?
Send me next slide, yeah.
Okay, so we've already know that requiring device enrollment is necessary to get security in IoT, but it isn't sufficient. And how do we know this? That lots of hackers have kindly showed us this. And if you don't have any examples that you can come up with, there are 3 here that you could follow the links for later. So what can we do beyond enrollment? Can I have the next slide? We also get from RFC 8520 that the things that we use in IoT have restricted roles and they have rigid communication constraints. So if we could enforce these, that could have prevented all of those attacks. So we have almost everything we need to do that enforcement. So one thing we want to look at is this notion that topic-based pub/sub is usually used at the application layer in IoT. And if we could get that topic visibility into the transport, now the transport could know what the publication's intent was. Now, if we think about having pub/sub in the transport, we have to secure that. That's going to require signing every publication in order to have provenance, because we're not going to be thinking about pipes between things. So if we could use that enrolled identity as our signing certificate, we've already got some pieces we need. But what we want to do is use chain of trust identities, because now we can put roles, capabilities, attributes, whatever we need to have can be in that chain. And if we have a shared root of trust for everything, it means that any of these enrolled entities can go ahead and validate any other members given the right methodology. So now every transport instance would know who is saying what, and if it knows the rules, it can enforce them. So this is what DEF does. Can I have the next slide? So if we take this approach, and this approach is pushing pub/sub into the transport, this is not MQTT. Now we get some benefits that go beyond security. We're now communicating with topics at the transport level instead of endpoints. And this notion is inherently broadcast friendly. So instead of having this, pipe-based end-to-end type communication, we're now order of N. We don't need brokers or hubs, so we eliminate a single point of failure attack, and we don't need endpoint identities, so we can just use link local self-assigned addresses. We've been using IPv6. And now security, the whole security game completely changes from what we've been doing. Could I have the next slide? So there's two big ideas that we're making use of in DEFT. And the first one is that we're taking trust management, that's how do we enforce those rules, and we're integrating it into the transport. And the second one that we're doing is we're embracing a broadcast physical layer by taking those topic-based collections at the transport. So instead of a model where you've got an application level pub sub and a broadcast layer here, and you're shoving everything into pipes in between, we're just embracing this all the way through. And DEFT uses trust schemas for the first one and set reconciliation for the second. And both of these are relatively recent advances. And each one of these could also be deployed separately from DEFT if you want. And particularly the first could be deployed with application pub sub protocols like MQTT. Can I have the next slide then? So here's kind of the basics of defined trust communications, is that we're going to always start with the configuration or bootstrap and just use any reasonable approach. There are a lot out there, and this is how we do enrollment. So enrollment is first necessary. But now what we enroll with is a little bit more specific. We have a bundle that contains the trust anchor for that particular trust domain, a trust schema cert, which is the rules compiled into a binary form and signed. And then we have an identity, which is the public cert chain, which is signed by the trust anchor at the top of the chain, and your private signing key. So the only thing there that needs to be kept secret is the private signing key. So we're assuming locally generated trust anchors, but this isn't required. You could do this, I suppose, with non-locally generated trust anchors. And our identities are distributed as chains of trust. I hope that's the right plural for chain of trust. And DEFT contains the validation methods that check this signing chain. And the chain is where we keep the roles, the attributes, and the capabilities. Can I see the next slide, please? So these rules can be really simple. They don't have to, tell you a lot about what each role can do. You could make it as simple as just saying that an enrolled identity signs all the domain communications. But you can certainly go beyond that to fairly fine-grained rules, which is the kinds of things that we've been experimenting with. And we have self-configuring privacy once you're enrolled via AEAD encryption. And you can update the trust schemas at any time by changing the rules, and you don't have to change your code. So if you think about this, you don't have to recompile code, you just have to get a new trust schema in there. And you could also take a trust schema, not the binary version, the text version, and make minor changes like the trust anchor and recompile it and use it in a different deployment. So I suspect pictures might be helpful. Can I have the next slide? Here's sort of a picture of what's going on. And if you look in the upper, up at the top here, we've got those trust requirements. This is what's done offline. What you want to do is you want to get your site policy, and then you want to get rules that come from standards, like what does a light bulb do? What does a light switch do? And we have very nice standards that lay those things out. You put those together into trust rules in a particular format, and then these go through a compiler, which comes out with a binary version of the trust rules for a particular trust domain. And then these are signed and put in a cert. And now if we look at the part that's on the device, most of it could be put into a trusted execution environment. That's part of the construction. So we've got the trust schema, we've got portions that do the validation of publications and portions that build your publications. And it's just the subscribe and publish that have to go through the call gates. The shim that talks to the device, that would be outside of the trusted execution environment. And the shim is translating between what the device says in terms of, I want to publish this, or I want to to say this and I want to receive that, it's going to translate between the publications both ways, between the device and the publication. So now what happens is we've set this up, say, so that the light bulb can only report its status. All it can do is say, I'm on or I'm off. I mean, obviously you could have different levels of on, but now if somebody puts something in that firmware that allows them to, say, activate a microphone that happened to be on the chip in the light bulb, there's no way for that to talk to the outside world because that publication would be rejected. It doesn't fit the trust schema, it doesn't fit the trust rules, it's out of here. Similarly, if somebody tries to send something that doesn't fit the trust rules, we reject that as soon as possible coming in from the network. Now, let's see the next slide. On the next slide, I want to go back to what we were saying in the beginning about enrollment not being sufficient. So here's what we do, right? Step one, we enroll that light bulb just in a way you do now, except that we use that bundle that I described earlier. In step two, that enrolled light bulb is going to join the trust domain, and it doesn't need any external servers or routers. It doesn't need to know who's already in the domain, and the things that are in the domain already don't need to know anything about the light bulb. So the light bulb comes in by saying, I publish my identity to the cert collection for this domain, and I subscribe to get everyone else's. And what's happening over here is we have a device that's our key maker, and it has to be something that's always on. And this particular device won the key maker election, and it's going to get this new cert that was published in the collection, which is a light bulb cert, and it's going to now encrypt the AEAD key and stick it out in that collection so that the light bulb can get it. So the light bulb has subscribed to that collection. Now it gets the AEAD key, and it's now able to publish. It can subscribe to the publications, and it can publish, and away it goes. But keep in mind that what it can do is listen to those publications, and it can listen to things that has its specific name. Maybe it's the kitchen sink light, or it can listen to the room that it's in, kitchen lights, or it can be everything on the ground floor or every light in the house. But that light can only report its status, and it can't issue any commands. So that takes care of that light bulb hack that was back on the earlier slide that was the checkpoint published on that a couple of years ago. So can I have the next slide? So this is sort of my final notes, that our goal for this draft is an independent submission informational RFC, but we're really looking for feedback on the draft to include it. I mean, it's just been a small number of us working on this, and it's just good to find out what we may have missed and what other things could be important. Possibly looking for collaborators on defined trust communications, but I'm not sure what that would look like, but if somebody has an idea, let me know. And the other thing we wanted to do is expose some of these new ideas about transport and security, because we thought they might be useful in other IETF work. And this work is completely open. We have a open source reference implementation that also has tools for looking at what you're working on, and also, examining trust schemas, and has some examples. Bug reports are welcome. We might be slow to respond. That doesn't mean we don't love to hear from you. We just are slow. And as I say, it's open. You should feel free to cannibalize parts of it for something else if it's useful in some way. And that's basically why we're here. So, question?
Yeah, there's already one hand in the air, so to speak. Dave is first.
Hello, Dave Taylor. So I have not yet read the draft, so thank you for this presentation, since I didn't know about this before, but this is looks great, meaning a couple things that I really like about this. If I understand right, you're using a trust execution environment, right? Your slide showed trust zone. And so the use of TEEs and IoT is
I just lost the sound. Did
Yeah, so what we seem to have here is a network partition, so we can hear ourselves here on the internet side, but the room is gone.
I have messaged Hank through a back channel to let him know what's going on, but I don't know if he will respond or not.
Okay, so I stopped hearing anything after he started to mention the trusted execution environment use and just barely mentioned it.
On
and I
IoT
did not-
devices, yeah. Yeah.
Yes, right.
I mean,
yeah.
the state of the art today, there aren't a lot of TEEs on IoT devices, I think is where he was trying to say.
Right. Well, we're not. We don't actually require that. I think that was meant to show how you could really get extra security here, and we're a little less concerned with today state of the art, the kind of thing that MUD was really meant to deal with, and kind of going forward, and some of the more special purpose uses. One of the collaborators here is Operant, and they can use trusted execution environments in the things that they're rolling up, right? So.
Sorry, I don't know where he was going from there, so I can't really continue.
Yeah, I don't know either, but I just want to make that clear that we don't require them, and it's just that if you really want to harden your security, and I think if you did read the draft, you can kind of see we're not really requiring it. We mentioned that as a way to deal with some possible security issues, and we think that's a good place to go going forward, because the world's just going to get, nastier in terms of attacking
I
things.
can hear you again. Sorry, Kathleen.
Hello.
Whatever you were saying, we had a on-site snafu a little bit here, so so Dave might have to repeat some of his question, maybe all of it, and maybe we reset the discussion from here.
Yeah,
okay?
go for all of it. Sure. Yeah.
Okay, so I'm going to back up to just comments, and then I actually have two technical questions, or maybe two halves of the same technical question. The comments were about the things that I really liked on your presentation was that you are using a trusted execution environment, right? You showed Trust Zone on your slide in IoT, and I wish more people would do that, use TEEs. Since you mentioned it was open source and that you wanted additional review, my suggestion was you might take this to the Confidential Computing Consortium and present it in the Technical Advisory Council meeting. By the way, I chair that meeting, so I can make sure you get on the agenda. And a couple people in this room are the typical attendees. But that organization sponsors open source projects. And since you have one, they would be very interested in hearing about use of TEEs in environments. And I think this would be very appropriate. So anyway, that was my CCC.
Okay. All right, I will email you later to get more information, maybe.
Yeah.
Okay.
Yep, great. And then on to my technical questions, because you mentioned, what's missing or what didn't you talk about that may or may not be in the draft, I don't know. But the first one is there's a number of IoT devices that roam around to different networks, like things that I carry on me. So how do you know, the first question is, how do you know that you're actually in the limited domain versus somewhere else? Okay, that was the first question. And then the second question is, how do you actually do discovery and setup, usually in the transport protocol? I mean, are you using DNS or do you have some discovery mechanism? And how do you know that the discovery mechanism isn't going on and then the non-limited domain and so on? So those are the topics that I was more interested in hearing more about. So.
Okay, so I want to, let's see, what was the first part of the question?
The first question was, if I have, say, two devices that are both on me and
roaming.
I'm now standing in the airport, can they still talk to each other because they're both my devices, but I'm in the airport instead of on my home network?
Yeah, so we aren't, that's not so much our problem space right now, but we do have a problem space where we connect different trust domains, or we're sort of extending them by putting them over something like a UDP or TCP connection. And I believe there's some stuff about that in the draft, and there is an example out there. And we hope eventually we have some ideas about like roaming around within a building where within a trust domain where we can sort of mesh devices. And I think a little bit of that is in the draft. And I have to say that's more our stuff that's kind of on the edge here. We're still working with that. But so far we're kind of encouraged. I've got a couple little examples I've been trying on that. But in terms of true mobility of, you carrying your device, like I said, to the airport and everything, that's something we'll have to think about. I think that we have a lot of the tools to do it. As to the other, it would be really nice if Van would answer this because he can, sort of use all the lingo, right? And he should be somewhere there. Van, could you answer the stuff about how we're kind of making use of what's in the link local IPv6, but we're not using DNS or anything. Okay, go for it.
Just what you said, Kathy, that hi Dave, long time no see. We're using IP6 Multicast for Rendezvous because it's defined to have exactly the semantic we want. It's link local, self-assigned addresses, guaranteed not to loop. And so because it's a very multicast friendly transport, we simply advertise in the appropriate topic that we have this information. If you know something that your peers don't, you give it to them. If they know something that you don't, they give it to you. And so everybody reconciles their collections, learns what they need to know. And as Kathy went through, first you do it for certs, so you've got everybody's identity. Then you do it for the trust zone's current nonce privacy key. And now you can start to publish publications based on the rules, which, because you're all in the, should have mentioned that the address that's used includes the trust zone identifier.
Trust domain.
We try to guarantee that everybody follows the same rules by the communication prefix is basically the hash of the signing key of the trust zone certificate of the rules. So so you're guaranteed to be talking about things that everybody agrees on their meaning.
Great, thank you, Van. As I understand it, if I understand the overall answer to my question, thank you for the details, by the way, that the protocol itself does its own discovery. It doesn't rely on some external mechanism like DNS or MDNS or something like that. Okay. I don't know how much time we have, if I have time for a follow-up question or.
Oh, yeah, there's enough time.
There is, okay. So follow-up question, which may just relate to the first question that I asked, is how do you know that you're in the limited domain? Is across different ways of doing discovery when you have privacy information, do you consider as being within the threat model? Do you consider the case where the network itself is untrusted? In other words, where you have, say, two entities that need to discover each other without revealing that they're part of the same trust domain on an untrusted network. Is that part of the threat model or not part of the threat model?
We can run on an untrusted network, and Van, you can jump in here if you want to, but we haven't considered like trying to hide the fact that we're in the domain, because we're hoping that what we're putting together here is good enough security. And as Van pointed out, sort of this detail that when we publish, we, it kind of shows which which trust domain you're part of. And I think that's, that kind of helps you find each other. And what you're doing is, publishing your certificates. And if you were to publish your certificate, this is maybe another detail, and you never see it show up in the collection, which basically means no one else is there to get it, then you would, presumably eventually give up, up call to the application, because that just means there's nobody else here in your, or maybe periodically you try again. So
yeah, thank you. I can explain why I'm asking the question. It's just whether there's other work that would be applicable to your use case or not within the space of, say, the MDNS domain. And I know you're not using that, right? But there was work there that said, if I have two devices, you're in the airport on an untrusted network, can they discover each other without revealing the fact that they are in the same, how do they discover each other without revealing the fact that that my devices or whatever? Where typically, like in TLS, one side reveals its certificate and the other side does not, right? And so you have to publish the fact that you're there. And so there's actually work that keeps perfect secrecy on both sides and still allowing discovery. And that work was done in the context of MDNS. If you care about that in your trust model, then you might be able to have similar approaches and just steal them from the other protocol work that was done. I think it might be an RFC now, I don't know, but it started like 5 years ago or something. Yeah, it didn't progress. Okay, well, Christian started it, but then somebody else that was a researcher and then took it over from there. I just know there's a body of work that says if you care about that trust model or that threat model, then there's a body of work for how to do oblivious discovery, if you will, on an untrusted network. So you may or may not care, but that was part of the follow-up on the airport question. So.
Okay, well, there's nothing you're not sort of saying, this is Dave Thaler's phone, right? You're just putting out the cert, right? You're broadcasting it. So
yeah,
I don't know.
If you're saying,
but yes, we haven't, right?
Yeah. Correct. If you say, I'm looking for anybody else that's in Dave Thaler's domain without saying that it's Dave Thaler's domain, right? Anyway.
Part of that is we include the trust schema hash in the Ip6 Multicast address. Mm-hmm. So you're rendezvousing on something that has extremely limited distribution, right? It's a cert that you made up at home. And that, to the extent that the domain supports Ip6 Multicast, then you can do the selective rendezvous and then pure authentication, so some sort of challenge response if you want to validate it. So look at this, but having this large multicast, having a broadcast rendezvous and then a large address space that you can play with to filter the rendezvous is a big help.
Yeah, I agree. Having a multicast group that is a hash of some security credential that you're rendezvousing on a multicast group out of a very large space actually helps the problem significantly. Yeah, that makes sense. So, all right, I see Brendan is in queue. Thank you for letting me ask you a bunch of questions. I find this really interesting. Would love to see this presented into the Confidential Computing Consortium. So, thank you.
Okay, great. And this is, by the way, this has been really fun to work on. I have to say that.
Happy to hear that. Then Brendan, before you step in line, I just want to point some attention to some remarks on the chat, which is, I think, from Carsten, who mentions, oh, that's a secret handshake problem again, and you might need unlinkability. So these are comments that you can, of course, discuss on the IETF list or directly with proponents here, sorry, contributors here. So
yeah, so the point about unlinkability was simply that the fact that you cannot make anything out of the trust schema hash is not the whole solution, because you still can link transmissions of that hash. So you actually have to protect that hash in such a way that only authorized people actually can find that hash, and unauthorized people have no idea what's going on, cannot distinguish the transmission from random bits.
I guess I'd have to know what the exposure is if things are private. I mean, I'm probably not understanding the question. I guess I'm not sure what the exposure is if somebody else knows those bits.
If I always find this particular trust schema hash at the airport at a particular point in time, I know the same person is there again. So that's the linkability issue, and we have to do something about linkability of transmissions.
I don't know if Dan has anything to say about this. I would just say, yeah, we hadn't thought about this so much for the, if you're going to the airport type thing, that you're moving around, and the mobility that may, and you're trying to find out the patterns of the person who's using that particular trust domain. That really wasn't our initial use case. There might be things or extensions that one could do. As I said, this is open, and if there's another use case that might be able to make use of some of this, that would be great. But Van might have something else to say.
Thank you.
Okay, sorry. Moving on to Brandon. This is this thread can be, and discussion can be continued on the list most certainly, but I want to give Brandon his mic time.
So I think that you may be focusing too much, and Karsten even may be focusing too much on the unlinkability problem, because there's actually a bigger one that shows up first, and that's simply traffic analysis. If you have communication partners in a untrusted domain, then you can link them regardless of discovery simply by monitoring their traffic and seeing challenge response patterns and things like that. So it doesn't take much analysis to discover that, unless you've got an extremely noisy network that prevents you from doing statistical analysis on the responses of devices. And that, I think, is going to be something that you have to consider if you actually want to make it visible, or sorry, make it invisible that two devices are talking to each other. The handshake is only the first step, and if you can't solve the second one, then solving a handshake doesn't really matter. The other aspect to this is that you're going to need to deal with the stalker problem. So if you have someone who visits a coffee shop once in a while, and they're carrying their device that's proudly announcing itself at the coffee shop, that tells everyone who's listening with a directional antenna or whatever that they're there. And if you don't want that, then you need to have something that's more than a hash of a trust domain, because that's simply going to announce the presence of an individual wherever they go. And that may be not something you're looking for, because you are creating a surveillance vehicle.
It doesn't announce the individual, right? It announces that it announces someone that is using that trust domain. So
if the trust domains
are
unique to an individual, then it becomes a unique identifier.
They are not unique to an individual. Okay. They're unique to a trust domain.
Are trust domains unique to individuals?
No. I mean, okay. They could be if you had, I guess, but I mean, that's not, the trust domain would be, for example, maybe an entire factory, or so all of the devices that are in it are in that trust domain. And when things publish, you're talking about two devices communicating, and we don't really think so much in that terms. Everything gets broadcast, right? So I guess if there's only two devices, you will see only two devices lighting up with that trust domain as their, starting bits. But if there are multiple devices, what you're going to see is it might be somewhat random who is responding when, someone is sending out something that's, kind of looking for more information or more publication.
No, indeed, I appreciate that. Sorry, I just, from some of the previous discussion, I had gotten the impression that trust domains could be personally unique. There was a comment earlier that it was made in a very limited scope, for example, and from that basis, then you can see how that would be a surveillance vehicle. So the point here is definitely do not make individual scoped trust domains, because that constructs a surveillance vehicle.
I think that would tend to apply to your use case, right? Like if your use case has a lot of mobility to it, then there are probably different things or techniques that we would want to use. And I think if what you're doing is being, if it's a factory, for example, maybe you don't need to change your trust domain often, but there's no reason that you couldn't change that a lot if it was just being used for a very small scope, that the individual was talking back to their home and they're moving around and you're worrying about being tracked. They can change their trust domain frequently. That's, that they could, that could be done. It's just, it isn't something we worried about for our use cases. But, I kind of hear what everybody's going to hear is going right to mobility. And what occurs to me is, maybe you would just, change it.
Okay.
So let me
I just wanted to raise it. So thank you.
Brandon, let me barge in here in the interest of time. Actually, we have some time, but Van is in a closed queue. Van, do you have some important, or is it, could you do this on the list? If you could do it on the list, you could lower your hand. Otherwise,
Yes, I'm trying to lower my hand. I can do it. Sure.
Okay. So two things. Have you spoken to Elliot, the ICE? And he's
just
already...
briefly, we've exchanged a couple of emails.
Okay, good. That's excellent. Also, what I just heard could be a security considerations content. So if you scope your trust domain too small, it might be a problem. So what you just discussed with Brandon, the surveillance systems you might be involuntarily constructing there, that is probably a part that could be discussed in the security consideration part of the document. So just I want to ask are there more questions, but unfortunately the time is a little bit short now. So thank you for your presentation. It was a pleasure.
Thanks for letting me present.
You're welcome. Let me quickly, I'm sharing nothing, I see. I will unlock the queue first. I will go to our next presentation. Time. Oh, there it is. Okay. And here again. And the floor is yours.
I'm not sure if I have mic. Yeah, I have one mic. Hello again. Thank you very much again, Hack, for the space for presenting a bit more about the draft issue. So I have made one short presentation in the Ops AWT session during the morning, and now I'm going to present some results of one running code test that I made during my research phase while I was producing this draft. So next slide, please.
Sorry, on it. There.
No problem. So this is the agenda. I'm going to introduce you about what I like to call in vitro experiment. It was one so much specific environment that we have developed with a running code test with issue. I'm going to show you the experiment results, and I will open some space to discuss a bit more about some other domains, IoT domains, that we maybe could expand the concepts of issue, and then talk a bit more about the next steps. Next slide, please. So this is the basic environment of the experiment that we have run. So we simulated one home IoT network and attacked this network with one Mirai variant, where the basic change that we made was installing the CNC server, the reporting, scanning report server, and also the infection server, all them in the edge node that would be more can exploit more the traffics allowed by MUD. So we have simulated this environment, and then we used 112 simulated devices, IoT devices, by running Docker BusyBox images with a vulnerable telnet server, vulnerable to Mirai. And well, we have built a network communication graph by using the MUD files, the 28 MUD files provided by MUDJIT from the University of South Wales. So we have basically 4 replicas from each MUD file that was described there, published there, and we used a Mirai variant. And in the next slide, we start to discuss the results. So next slide, please. Well, we basically have had the measurement of 5 basic metrics: the number of the DDoS packets generated, transmitted, and also the number of bots that could communicate with the command and control server, the number of bots that was scanned and reported to the reporting server, and the number of new infections after the starting of the scenarios. And they had different scenarios also, with all IoT devices infected, with the edge node infected, and 2 scenarios where different kinds of IoT devices infected inside the network, and they run during 20 minutes this experiment in 3 kinds of protection in the same network: the network with non-protection, the network with the protection provided by MUD itself, the RFC8520, and the protection provided by issue. So we can see in the leftmost, for example, the worst scenario where it was possible, with all the devices in the network infected in one network with non-protection. So we in about 20 minutes, and if I'm not, I think that it was 4 rounds of DDoS attacks. We had something between 2.5 and 3 million of packets generated and transmitted by the network in the network with non-protection. And in the case of, in the same scenario where with mud, with the protection of mud, we had a little less than 1.5 million packets generated, but almost non-transmitted because mud has a good protection of packets of communication with hosts outside my internal network. So we had a high number of packets generated, but almost not transmitted. We have some of those scenarios, but if you look at the rightmost side of this chart, we will see all the scenarios where we use it in SHU. So we could not identify any generation or transmission of DDoS packets in the scenarios that we have experimented. So next slide, please. And in this chart, we see the number of controllable bots and new infections and scanned nodes, and we see basically why we had some of that numbers, or some of those numbers, were in the leftmost part. We can see that all the bots in the network without any protection could connect to the command and control of Mirai.net, and is in a similar manner. We can see that MUD still allowed some devices, 40 devices from the 112 devices, could connect to the command and control server, and then could generate the DOS traffic, but the other metrics like new infection and scanning was smaller in the MUD scenarios. But in issue, we did not have any DDoS packet generated because none of the bots could be controlled, even when infected. We did not have any new infection, and also it did not have new scanning and so on. So basically, in the specific scenario that we tested, it should block it, all the operation traffic of the Mirai.net. So this is basically what we had during our experiment. Next slide, twice actually. I'm not gonna use this one, so next please. Okay, so besides the home IoT scenario, we are also studying some other scenarios to expand the issue proposal. So the first one that we are thinking about to work also with issue is in the scenario of smart cities, where we have similar topologies and heterogeneity of devices. We have the same scenario with a small SOC taking care of big infrastructures, and well, different from the home IoT scenario in smart cities, we can consider that we understand better the running applications. We can understand better the running applications inside my network, and that we also have more computing power available. And a second branch of this proposal, of this study, of issue, is to run it also in industrial IoT. We are running one research now in this field, but we are still in the early days, where we have critical system running, and we have the full understanding of the and control of the running applications. This means that we understand better, we can understand better what kinds of traffics that we can block, for example, how it will affect my industry, my industrial plant. So this can give us more control about also the decisions made based on in issue rules, in issue actions. And we are trying to do it in top of Modbus or Profibus networks. So we are still in the early days, but we think that here we can maybe have something. So That's all for now. I think I have 2 more slides, but I'm not gonna use them. So please feel free to make any comments. We are open to new contributors, new contributions, any questions or anything else.
So yeah, thank you. From the room or on the remote side, any comments or questions about this? I mean, we might have seen this already in OPSA, so the uptake might be a little bit low, but in any case, is there still additional comments on this work? Otherwise, I always give a thumbs up for the practical side of things, so thank you for that. But if there's no other questions from the room here, thank you for your time and your presentation. And I'd like to change to our final presentation then, which I have to find again. Of course, there's a trigger word there. And Brandon, it's you.
Yes, I presented this one. Actually, I've presented it twice in the past, and it's in a slightly new form now. I think it's much better now. The new format for this draft. Next slide, please. Yeah, forget everything. I've stripped out most of the text from version 0. I've kept a few things around, but it's roughly the same content in a much, hopefully, better form. Next, please. So the question is, what is the root of a security architecture? And I would argue that the root of it is knowing which threats it mitigates. If you don't know which threats your security architecture mitigates, all you have at the end is a warm, fuzzy feeling. And that may not be helpful. So I maintain that all security architectures should have threat models. So since I didn't have one, I've put one in. So IoT Nets now has a threat model, some guiding usability requirements, some risks, some mitigations for those threats, and technologies to implement the mitigations. This was an attempt to approach the ask that Elliot Lear gave me after the initial draft, which was essentially a menu of technologies and why you might want to use them. Next slide, please.
Oh, come on.
So I've covered 10 top-level threats. Some of them have a few sub-threats, and I could go through them all here, but honestly, it's better to go through the draft and have a look at them. The important thing here is that these are all threats that probably have relevance in networks containing IoT devices. A lot of them have to do with threats directly against the devices. Some of them also have to do with threats against the network. Next slide, please. So I've covered a set of technologies, 9 of them in total, although you'll see that the device isolation ones actually span out quite a lot to substantially more there. These cover technologies that are developed in the IETF and a few from outside, largely to do with provisioning. They are primarily security technologies. Next slide, please. There are a lot of things that are not in the draft. The current threat model is quite minimal. It covers essentially just the things that are necessary to justify the technologies that I put in. There's probably a lot more threats that we need to look at it. The technologies that I've covered are fairly minimal. There's no mention of transports, for example. So things like TLS, DTLS, CoAP, none of that is in this draft. I'm not sure if it belongs there or not. I'd appreciate feedback on that. And there's missing guidance on non-security aspects of IoT ops. For example, human readable formats do not belong on constrained nodes. So I haven't put anything about that in there. Maybe I should. Maybe we should. Authors welcome. Or maybe that needs to be a different draft entirely, but I could see an argument for guiding principles on the interoperability of IoT devices. Next slide, please. Yes, authors, if you have strong feelings about this area, please join in. This is not going to be a great work unless there are lots of viewpoints and lots of input. Otherwise, you're just going to get a document that writes down Brendan's opinions. And I'm not sure that's what everyone needs. So please contribute, and please let me know if you would like to add to this. And with that, in this 30 seconds I've taken to go through my slide deck, I'd be happy to talk about anything else in this. If there are any questions or comments or things that are obvious that I've missed, etc., etc.
Mike is already moving to the mic.
Hi, Michael Richardson here. I think I read 00 and I think I read 01. I'm not keen on the rec stuff and the titles. I think I said that already. I don't think the title reflects the content of the document.
Not anymore.
So that's something to think about. And I guess it's a little bit abruptly ends from section 2 and suddenly goes into normative references. And somehow I feel like we, at least there should be a security considerations heading in there, right?
Well, I mean, the whole document.
This whole document is about security, yes. But so without criticizing any specific part of the document, I'm unclear what the actionable outcomes of this for the reader are. And that's maybe something that we really need to discuss about that, right? So I'm happy to have a, what's the right word, a survey document of IETF specs and other specs that are important, and that's part of the purpose of this working group. So I'm not saying we shouldn't do it. I'm just saying that if there, we need to think about what the reader's next step is when they get this document, okay? And that may take a little bit of thinking as to what we're really doing. And I guess, Hank, we were supposed to have a what are we doing the next year discussion, and we haven't had that last time, and I don't think we're having it this time.
Oh, no, this is evolving into that, actually.
Yeah, okay.
Yep.
Well, I think we actually,
Right
given
now.
that we lost one co-chair and we had the internet go down, we might, I said this last time, actually, that
Pending
maybe we need to do this, and it's Friday afternoon, and we're probably all baked. Maybe we need to do this as a virtual interim where we can actually just focus on that one topic for that. And I think this document actually may take us there, right? So they're not, as you said, unconnected. But anyway, thank you, Brendan. I would definitely contribute more things to it. I see it is a bit thin, and I think we can go quite extensively on some of the items. The question I think really is, again, is let's figure out what we're trying to tell people here, and what the conclusion is supposed to be. Let's write the conclusion first, right?
The goal was to be a landing pad document for IoT security, and say, this is a broad scope of different things that you may encounter as a IoT device vendor or IoT network vendor. And this is, the sort of things that you may encounter, the sort of concerns you may have. And if you have such a concern, then here are the ways that you get around it. Here are the solutions to the problem that you just discovered you have.
So I understood that there's, and Michael, I will remove your hand, that there was one person who has read the minus the -01. So what I'm going to put through here is this. Did anybody else? This is a pop quiz.
Do I raise my hand as the author?
Nope. You know it by memory. Recite the first sentence. Okay, so apparently Michael is correct. This can't be a thing we can talk about content-wise today. We have only 2 people actually have read it. But I think this one I would encourage actually to read to prepare for a set virtual interim. Yes, we are all back. This is a Friday zombie slot, but still, I think that was something I wanted to know, and here we go. So I'm capturing this result, and I will do another one. This is helpful. There's another pop quiz. So who will probably in the position to review this in order to bring it in shape? I heard that security consideration by this document basically is security consideration, might be something that is not so easy. And also that this could be a map that is really helpful. And that there's critical mass. And I think 4 is critical mass. There we go.
Perfect.
Yeah, so I wanted to see at least 4 hands, otherwise I would be like, okay, this is way too Friday. Okay, get in contact with Brandon. We can chat on the list and we can create a virtual interim for this kind of work. We can co-locate a comparison document that we're talking about, but there's no document yet, so that might be a little bit premature. I will talk with Hannes about him nuclear doing something there. And so I will end this poll. And yeah, this is basically what I wanted to see. If this could be something that the majority of the working group has a consensus with, then we can actually start to adopt our first document. But it's important that we actually involve the people. So we have to float this a little bit. That's on all of the here in the group right now who can hear me, who might eventually read the minutes and then go from there. So I would agree with Michael that we can't really have a content discussion unless there's still some questions or comments in the room or from remote. Going once, going twice. Okay, but people will read the draft. I like that. So please do. And then I think November is a little bit in the future. We can have a fine interim on a single topic, I think. And with that, if there's no any other business, I would say we adjourn this meeting. Thank you, Brandon.
Thank you.
Thank you, all the other presenters, and thank you for staying up so late, I want to say, but it was an excellent IETF. Bye-bye. Yeah, adjourn means done. We never really end. We just pause. Swoosh. And Warren, you have to show me what you did, what magic you did with the thing.
I didn't. You're right. They fixed it from the
The remote effect. Oh, because I was like, you're a magician.
Yeah.
Okay.
Wi-Fi sensing.
Yeah.
The sense through going up.
I can't put this off.
All right. So where's my Star Trek teleporter? What do you need to get to? Mars. I don't want to go into Century, though. I want to go to Century. One where it's like, yeah, well, no, I don't. As long as it's got big built domes.
There's not a lot of attributes to that. Like,
Just make sure you bring your mask.
Stone that actually has oxygen in it.
Make sure you bring your mask.
Bring my mask.
The mask atmosphere is not
Alternately,
Hi there.